I'm going to go ahead and start here. Um, Merry Christmas. We're in the midst of the Christmas season. I guess we have, I'm surprised that this many people are here this morning, given that I'm surprised I'm here this morning. Okay, I invited Andy to come by and tell us a little bit about himself. We don't know Andy, and invited him. He's been participating in a couple of email discussions. He was introduced to us by Jerry, who I don't think Jerry's here. And I guess you know Jerry. And Jerry said, well, there's this guy that, so I put you on the email list. So you prepared a small presentation, about 30 minutes, I think, to explain what your ideas are. And so this will be something different. So why don't you go ahead, Andy?
All right. Well, I'm not really used to oral presentations, so bear with me. I just write, so this is my first presentation to anybody verbally. It's been kind of a pride and passion of mine since I was...
All right, before you start, tell us a little bit about who you are, where you live.
My name is Andy Schulteis. I didn't set my profile, I guess, on this Zoom thing. Let's see if I can change. I'm not going to worry about that right now. I live in Virginia. I work for a printing company, actually. So I'm not in the physics field.
Where do you live in Virginia?
Chesapeake.
So you're just across the river from me. All right.
Oh, okay.
I'm in Newport News.
Okay. Yeah, we run trucks up there all the time. So,
all right.
That's pretty much who I am. I'm a literal nobody in this field. But I've been, researching it since I was a teenager, natural curiosity about the universe. And, when the internet came out in the 90s is when I was really able to kind of move forward a little bit. And I can share this slideshow and maybe start.
Well, go ahead.
So, should I just start?
All right.
Screen if you want.
I'm sorry. Yeah. I missed that last night. Jerry helped me test some of this stuff before. Hang on. Is not turned on. Okay.
Oh, I've approved it.
Okay.
Now, when there should be a screen that comes up that gives you, you see the screen that comes up and it should give you, okay, there it is.
All right. All right. Can everybody see that?
That's good.
All right, I call this the persistent universe. And what this represents is a fractal structure where I think it's a nested hierarchy of universes. Now, I don't like to get real involved in multiverses, but this is kind of the framework that I see, and I think we're all in black holes, basically. And the reason I think that is because when you observe the universe, what you see is a lot of process duplication. Right, matter duplicates, we got planets and stars, a very finite number of things that go on. So I kind of look at galaxies as a womb, basically, and a black hole as the seed to a new universe. So I think we have universes parallel to us, above us, and below us, and it's just a nested hierarchy that runs all the way out, unimaginably deep. I don't see it as infinite in the classical sense. I don't see the universe as infinite in the classical sense. I think it's kind of a mix of both infinite and finite, and my view of infinity is that it's more a dynamic term, and finite would be static points within that dynamic state. So like a finite transition point would be where matter would collapse into a black hole. So we see that finite element, but the universe itself is not classically finite or classically infinite. It's kind of a mix of both. And the reason I think it's like that is because if you look at a Big Bang model, it kind of leads you to believe that it's like an over unity machine, right? It blew up from nothing, expanded, now it's accelerating. And I think you have to follow the laws of physics to understand. You have a classically infinite universe that's static. This kind of implies that it's a perpetual motion machine, right? You're just going to run out of energy. You're going to run out of motion. It's going to just die and, fade away. But in this structure, the universe is feeding off a potential state that lies well beyond our view. It's kind of the way that I see it. So it just keeps flowing. Okay, it's a constant dynamic flow. I'm going to skip through some of these. I've got about 17 slides here. This is, basically a summary of, when I started, and I took it more seriously in the 90s. Okay, this investigation, and that's because, information opened up and it was easy to talk with people. So I jumped online and I found myself, let's go here. Basically, when I started this, I had just a couple of basic questions. Not knowing anything about physics, I had never stepped foot in a physics classroom. I don't have a math background, so it's kind of been a mathless formula. But it's just my imagination, okay? Seeing the mechanics in my mind and how all this could connect and work. So the first thing I ever wrote about, I called the universal engine, right? And the questions I asked was, what is existence? Why is everything in motion, and what animates the universe? Which I think are probably the most fundamental questions we'd want to answer, right? So I'm looking at it from a 50,000 foot view, basically. Very general, and starting at the very beginning, what are the basic variables that create the universe? What could it possibly be? Where I start is just 0 and 1. Try and understand what that means. And it's so space nobody really looks at, right? Everybody's in the middle of the universe, in this complexity, looking outward, trying to understand it all. Well, I'm just trying to understand 0 and 1. What does that mean in relation to the universe? Those are kind of binding points where all of our math connects, okay? And a 0 being absolutely nothing and 1 being something. It's an age-old question. So I've basically come to the conclusion that there's a difference between an absolute 0 and a regular 0, and an absolute 1 and a regular 1. Okay, 0 and 1 in our view, in our relative view, is a placeholder for some other value, where absolute 0 is absolutely nothing, and absolute 1 is absolutely everything. You could look at that as space. Okay, and that's what I see it as, is, absolute 1 is space, void of all motion and energy, and it's a potential state. So the first place I ever ended up was with a man named Dan McCoyne. Okay, and this is where I uploaded my universal engine to, right? And I was kind of nervous that I would be laughed out of, existence, right? But Dan, was a very pragmatic man. He passed away in 2008. Very pragmatic man that, wanted ideas and for his theory. But he basically saw the universe as a unified kinetic energy field. And he didn't believe in Einstein's speed limits or anything like that. And he was trying to build, a theory. And he's an engineer and dealt a lot with energy, and very nice guy. But anyway, in 2008, okay, I had a eureka moment, if you want to call it that. I flipped the picture around on the Big Bang. 180 degrees. And I just saw a different universe and the way it could possibly exist, where matter is condensing inward and space is expanding outward. Okay, and that kind of tied back to Einstein's 1917 equations, where he came to his field equations, and which told him that the universe didn't have any preference towards expansion or contraction. And at that point, Einstein, back in those days, and I think you have to really look at history quite a bit to understand the way they were thinking back then when they developed all these theories. He didn't really want a contracting universe or an expanding universe. He wanted a static universe, because the prevailing sentiment back then was a static infinite universe, and that was it, right? So he inserted that lambda in there, the cosmological constant, to try to get the thing to balance out. And then he recanted it after the Hubble, obviously, and we moved on. The universe started from a little speck, and it blew up, and that's where we're at today. And then I guess back in the up in the 90s, they knocked the dust off that thing after the observation of the acceleration, and then inserted it back into the model. But I think it was wrong. I don't think they should have done that. But so let me see. Now you fast forward, okay, some of the things that have always bugged me is light, okay, the speed of light. All right, it's a very slow speed and feels kind of arbitrary. Okay, if you square light, 300 billion times faster between 2 points, the speed of light is just strangely slow. Right? It doesn't make any sense. Put that into perspective, if you look between, 1 second compared to c squared, right? We're down here. All of our whole existence sits right in this little spot. And to me, that looks weird, looks funny. Okay, so there's something we don't understand about all this space up here. I mean, you could take the square root of c and just keep going on indefinitely, right, in one direction. And that c is going to keep pushing this way the smaller you get that motion, but you're never going to hit 0, Or you could take c squared and do that indefinitely, and that's going to take that motion and push it way back. So what does that mean, right? It doesn't make any sense to me. So these are things that go on in my mind, and I don't have any math to explain that, right? But I can clearly see there's something weird that doesn't fit or make sense. Hang on, bear with me 1 second. I'm going to blow through some of these slides and get down to the meat of what I'm talking about. Okay, the core assertions that I have is that space is fundamental energy. Okay, that's what everything is made of. That's the top dog, physicality of the universe. That's what matter is. That's what space is. It's all made from the same substrate. And space is also dimensionless, which contradicts our 3D view of the universe. And the rationale that I have there is that space, you can't even imagine it doesn't go on forever. I think it would be ridiculous to think that there's any dimension at all to it. There's no end, so you can't really define a length and a width when you look at space by itself. What endows it with dimension, I think, in our view, is motion. Okay, once motion gets set, okay, the space can start collapsing, and then we can start defining dimension based on motion. And then time, okay, is really encoded information for motion in space. Okay, it's not a separate dimension. It's all wrapped up in these 3 simple variables, which is space, motion, and time. Okay, so matter is in a contracted state, and space is in an expanded state. And space is a unified entity. Okay, there's no cuts or breaks in it. It's just a solid, like a bowl of Jello. And where our matter is made of the same stuff inside, and it's contracting inward. The density and the energy is increasing as it contracts. And that's what's kind of regulating our time, the way we see time, depending on the density of matter or mass. So mass is, let's see. So these are some of the core assumptions. Time is how we perceive transformations of energy, okay, which is derived from the motion of space, okay, and it's a product of space times mass, okay, and there's an inverse equivalence between time and motion. Okay, so as long as, let me see, I think the next one might explain it better. Yeah, so we get into this one. This is probably a better slide. Okay, now I'm going to ignore the absolute extremes, okay, the absolute 0 and the absolute 1. So we're just going to get down to these relative markers. Okay, 0 isn't really 0. Okay, that's another value. Okay, 1 really isn't 1, it's another value. But from our perspective and our physics and our understanding of the universe, these are real limits. So if you look down at this one, when motion equals 1, okay, which would be its maximum actualization, 100%, you know, between 2 points. If you were to move from A to B at a speed of 1, it would be instantaneous. So with that velocity, there'd be no time to record. So your perception of time would go down to 0. And your perception of space would go down to 0. Okay, and conversely, if there's no motion, okay, time goes to full actualization. And space goes to full actualization. So things get bigger, right? So then there's a hierarchical order to it all. Okay, space would be first, that's the physical. Motion would be second, okay, which is the actualization of space. And this is the energy. And time is the encoded information where we see motion in space. And that depends on what this 1 means, okay? But because it's an inverse equivalent, okay, here, it's always going to look like 1, so you don't know what that means. But that's our relative perspective. It stays static as long as motion is greater than 0 and less than 1. So this is our relative view of the world, okay, of the universe, of everything, and it really is dictated by our energy density. And if you go to the extreme ends, okay, where you're up here, m equals 0, t equals 1, s equals 1, m times s equals 0. So this isn't really something we can see, which is defines space really, right? It's something that's kind of transparent to our mass. We move around in it freely, it looks like nothing, it feels like nothing, but it's not nothing, it is actually energy, you know, the base energy. Now we perceive time in the form of actualized energy transformations. Okay, so this m times s equals 0 is something that slips out of our perception, but we can still see it indirectly. Okay, and we're seeing that in the form of gravity, distance. So I come down to here and I say, okay, well, our universe must be dictated by density. Okay, so I've got c equals 0, so c is actually our lowest density, and c squared is our highest density. And this really is dictating our entire universe. Okay, there's a lower bound limit of c, which is you convert to a density, and an upper bound limit of c squared, which you convert to a density, and this describes the entire universe. This is space. Okay, a black hole would be at c squared, you know, the highest density of space. Okay, and this is the maximum density that space can handle before it breaks out of our view. And this is the lowest density of c. Okay, this is the space itself is here. Okay, this is what space represents. S equals 1, m equals 0, t equals 1. And that value, that density, that static density in the void is going to be c. Around black holes, it's going to be c squared. So it's pretty simple, right? So what I ended up with, based on that little bit of information, is a new formula. Okay, something I'm calling a tether formula, and I'm using a lot of AI to do this at this point. All this is beyond me. You know, I'm not a physicist. I don't understand all these formulas when you get down into the nitty-gritty. I can't do them myself. I can follow along with what's going on. Okay, but it's a time energy density ratio. Okay, and that, you know, you go back to here, right, and you can see just these variables, you can only do so many things with them, right? You've got, okay, we know time equals space, okay, mathematically speaking. Okay, you can divide, okay, this is the inverse equivalence between time and motion, okay, which you can see is going on here. When m equals 0, t equals 1. When m equals 1, t equals 0. So there's an inverse relationship between motion and time. So that allows you to look at these, and that's where I came up with this. Okay, and I put this down as a ratio, an energy density ratio, to describe the universe. And what I'm really amazed with is how well it's working for light. I mean, this formula ignores general relativity, special relativity, and you can plug these in and you actually you match results, known results, without using any of the conventional mathematics and physics.
Andy, what does the delta mean?
It's a gradient, an energy gradient based on the mass.
Oh, okay. All right.
Mass density. And this is stuff I'm just learning. Okay? I've never had a need to go this far with what I'm doing. Okay, I'm just constructing a model, what makes sense to me as a human being, imagining these mechanics in my head and how they work. Okay, so I had to learn what a delta was, and I had to learn what a scalar field was. Okay, because when you get into here, okay, the way this formula is working is I have a scalar field in here, okay, which dictates density from c to c squared. Okay, and when I plug this into AI and said we'll use these parameters for the scalar field, and then calculate out, you know, some anomaly, right, of light, gravitational lensing or redshifting, the values were way off. Okay, way off when I did it just straight up. And I said, well, we'll add the inverse square law into it. And once I did that, they nailed it right on the button. Every observation. You can describe gravitational lensing with this. You can describe redshift with this. And I got around neutron stars, and the AI had to add some mass in there to make that work. But it's a first principle calculation. There's no other added elements in it at all. And I'm just kind of shocked that it's working, you know, because I'm not you guys. I mean, I know you guys are brilliant. You know all this stuff inside now. And I'm just tinkering.
You seem to have a scalar on the left-hand side of that proportionality and a vector on the other side, I think, which seems to be a bit strange. Do you follow? Like the energy density, I think you're calling FG, and the gradient is a vector.
Yeah, you would probably be able to explain this formula that I created better than I can.
I just find it a bit strange, but anyway. Go on.
It works though, which is the amazing thing. And you can apply it to anything, it seems, that has to do with light right now. And right now I'm in the middle of trying to find a coupling constant where I can tie this back to mass. But a lot of this is getting over my head. I'm heavily reliant on AI giving me these answers at this point. And I can tell it what I want it to look for, right? And so I know what I'm looking for. I just don't know how to describe it mathematically. So I have to let the machine do the work for me. But it's working. And this kind of gives you a framework of the universe the way I see it, that's driven by this this time energy density formula. Okay, this would be the way we would see it in a synchronized state, you know, looking at your coffee mug on your table. Okay, the center is the timeline, how we view everything. Okay, and down at the bottom is kind of what quantum mechanics is dabbling in. Okay, they're down here in this level. General relativity is looking up here at this level of density. Okay, so the physics are going to be a little bit different. Okay, but it's very simple. If you bend that line, right, you increase mass density, okay, you're smaller, so your view of space expands. So distances go out depending on what your density is. Okay, and if you go the other way, okay, and you expand, okay, that's going to contract the way you view space. So this is what we see, okay, when we're looking at each other and we're all in the same density, the same relativity, okay, time all looks the same. Okay, you go into a dense field, right, a denser area of space, right, relative to you over here, and time is going to look different, space is going to look different, matter is going to look different. Okay, when you're comparing the two sides of the problem. Okay, and then this would be an expanded state of mass. Okay, and I think when we actually observe relative motion, okay, we aren't really gaining mass per se. What we're gaining is potential energy. Okay, we're moving more towards a M equals 0, S equals 1, T equals 1 state. Okay, so we're increasing our potential energy when we move, which alters the way time looks. So this is where I'm at with it all right now, and it's really going beyond my abilities, okay, beyond my capabilities to take this any further. And this was kind of interesting. I read a lot of, current articles on scientific experiments, right? And I just happened to catch one last night, okay, where, let's see, scientists said that they saw negative time in one of their quantum experiments. Okay, and they struggle to explain things like this, and it ends up in debate and whatnot. So I took that entire article, right, explaining that they've actually seen negative time now, and I dumped it in there, and I said, well, apply my formula to it, okay, and tell me what it means. So it goes out and does a calculation, and then it explains it for me so I can see why. But it does a great job doing it. It is getting down on the quantum level. It understands it all. So it's quirk, not a revolution, in short. Okay, I could share this thread out to people too if they want to see it. And see how I'm arriving at these answers. But it's I'm at the end of the line here. I can't really. It's very slow progress for me at this point because I can't take it any further. This is
Andy,
beyond.
okay.
Yeah.
Yeah, could you said you could share the spread out?
The what?
You said you could share the spread out. Does that mean you could share the information that we could put into AI ourselves?
Absolutely.
Okay, I think that would be useful for me. I would like that as a kind of a starting point.
Yeah, I will. And there's I use ChatGPT, and I don't know what you guys are using, but that O1 model, the advanced reasoning one, it's a huge leap from the other versions of it. It's like having your own personal physics slave to do your work. It's very pragmatic. It doesn't When you're into the 3.5 or the 4 version, it's a little bit too much of a cheerleader, so you got to be careful with it. Okay, it's very excited to help you. It doesn't want to offend you. This one is very rigid on the O1, so if you've got access to the O1, and I know if you're paying for the service, you get a limited amount of posts that you can do in the O1 before it'll, die on you. But
Okay. Yeah, does it happen to show you the work as it goes along? Or you say
Yeah.
the results. So there are equations in between that it could show you what it's doing.
Yeah, give you an idea. And for me, it gets to be all Greek.
I see. For me, it might be useful sometime for you or someone else that's more familiar with that ChatGPT to maybe demonstrate how to use that.
You ask it, it just takes your information and it does the work. You're foolish not using it if you aren't. It just, especially the O1 model.
Well, okay, at this point I'm foolish.
Don't mean to insult anybody.
No, that's fine. I have no problem with that.
We only have 7 minutes left. Andy, are you wrapping this up now, or?
Yeah, I think I am. I've gone, I think, as far as I can. I have a working formula that's describing the whole universe with 3 variables.
Well, that's impressive.
Andy, at this point, does it work just with like mass and gravitation forces and not electromagnetic forces?
It'll work on all that. It'll work anything that's massless. It'll work on out of the box.
Yeah, but have you tried it with anything that describes electromagnetic functions?
You want me to do it right now?
Well, we only got a couple minutes left. So.
Well, it takes a second to this one.
All right, I'd like to open it up if anybody's got any questions or anything, because we only got like a few minutes left to go here before the meeting ends.
Well, just one general point about ChatGPT and so on, which I have used on occasion. This AI system is really a consolidation of all the information out there, which means that it would be highly reliant upon conventional physics. Now, this is the type of physics that we are questioning and attacking. Roger Anderson, for example, has put questions into ChatGPT about Einstein's theory, and it's given him back the conventional views that we decry. So I'm a little concerned that a lot of this information that you got back, Andy, might be questionable, to say the least.
That's fair.
Giving the right answer.
That's fair, but I understand how this software works, in the nuts and bolts. And what you need to do if you've got a new theory is you have to train it into your way of thinking, and you have to push out conventional, physics, basically. So you train a thread. These threads are trained on my model. And when you're in the O1, it's completely different. If you're asking 3.5 or 4.0 a question, it's different from asking O1. This is actually doing some reasoning. It's actually, you ask it to do something and it'll give it a shot. Now here's electromagnetism explained through the Tedder formula that I've got. So it will give you an interpretation of the way I'm seeing the universe based on my formula. And anything that's massless you can apply this to is what I'm seeing. So down in the quantum level, if there's some massless phenomena in there, it will answer it. It will tell you and it will explain it to you and how it works in English. And you guys would understand this way more than I will. Because you understand all these symbols. I don't even know what half these symbols mean. I know what a scalar one looks like now, right? But I'm not a this.
You say it understands it in English. Does it give you any graphics at all? Like when it starts to talk about the motion of the energy in that, does it give you the diagrams of the energy density or anything like that?
Yeah, it can draw graphics. I'm not sure. Oh, I haven't tried that in O1 yet. I know 4.0 can.
Yeah.
Okay, but I find it chokes quite a bit on some of these graphics because I think the math is pretty intense.
Yeah.
But O1 is there's a lot more bandwidth they opened up on it, and
Yeah.
a lot more reasoning connections they put in it.
Okay. Well, I'm a visual learner too, and I do a lot of my research and basically an observation of physical actions and motions and stuff like that. And much of my theory is based on observations like that. And it looks like you've got the math that kind of goes along with it. I think it fits very well together.
Yeah, here it can do some graphs in ASCII. I guess O1 can't really do a lot of the picture drawing, but there's a graphical representation of the question I punched into it that you asked about, and applying my TM formula to it.
So I'm curious.
I'll share this out to everybody.
That's pretty general. It doesn't really give too much information there. Thanks.
I'm curious as to what Jim has to say about this.
Me? Well, I noticed that time was defined as the product of S and M, and then the very next statement was that time is inversely related to M. And so, of course, the first statement is that time is directly proportional to M, so that there's a contradiction. Barely a minute passes before we have a basic contradiction presented.
Yeah, and that could be some of my explanation. I'm not a physicist. I'm just telling you what I see in the numbers. Time and motion.
So you don't see the contradiction then?
No, I didn't see the contradiction.
You don't have to be a physicist to see the contradiction. It's sort of like elementary school algebra. You said time is equal to S times M, which means that time is proportional to M, and S being the proportionality constant. Then you said a moment later, time is inversely proportional to M, and said that M is inversely proportional to time in case we didn't get it the first time. But that's a contradiction. So that you might want to remove the contradictions, because I don't see where ChatGPT or anyone else can be of any assistance to you when you're starting with a basic contradiction. I don't expect an answer right now, but I was asked for my comment, and that's my comment.
Okay.
All right, we got less than a minute. Anybody else? All right, some of us are back. Vladimir, I don't see Vladimir. I thought that was an interesting presentation. Actually, I thought it was kind of really interesting.
I think it's very interesting.
Perhaps those of us who think traditionally maybe didn't understand it. What about you, Jerry? Did you understand it?
Well, I have had extensive conversations with Andy, for quite some time through the CMPS forums. Also, 2 Zoom calls we've had, and we've had some very intriguing conversations. So I ask constant questions, and I don't really grasp his views. As far as ChatGPT goes, the ordinary version that I have, I repeatedly ask it questions involving relativity, and it cleverly avoids answers. It's caught up in contradictions all the time, and it won't admit anything. So it's sort of frustrating. I don't know if anything that adds to the confusion. Maybe that's just a speculation that it might encourage, just to add to the confusion. They don't want people to know the actual truth. I don't know. That's just a speculation, man. But
this is kind of where I think it would be useful to have, if Andy is familiar with ChatGPT and efficient at it, it would be useful for him to demonstrate how to use it for us.
Oh, well, Cornelius, it's quite easy, actually. All you have to do is just simply ask it questions. You can type in any ideas, you can ask it, what is your view? You can even ask it, well, can you polish up this manuscript for me? I mean, it does all sorts of things.
I've used it generally, but I mean, I'm talking about to get results like Andy's getting. I've used AI generally, but and a little bit of ChatGPT, but I'm just talking about to get the kind of results and the depth that Andy is getting. I think takes a little bit more knowledge.
Oh yeah, I would say so.
Okay, so that's what I was.
Probably more advanced. Well,
that's what I was.
Cornelius, wouldn't you say that Andy's view of space correlates to the ether? I think you mentioned that in one of the group emails, and I thought similarly. As far as space being the only physical thing that exists, and that it sort of, well, I don't know if his view is that it actually creates objects or manifests them somehow, similar to how particles exist as excitation within the field or the ether. Because I view space as emptiness, a void, in which the phenomenon fills.
Yeah, I think I've defined what I call the ether, and it fits in well with results that Andy's getting. But Andy basically is, it's a matter of semantics. Like he said in his letter there, you can give space certain characteristics, and then it can become your ether, basically. But the way, it depends on who defines it. I mean, Einstein defined it as the ether was basically the basis for the space-time standards. Without the ether, there wouldn't be any space-time standards. Andy's just at one level above. He's talking about space-time, regardless of whether he likes the word or not. He's not just talking about simply space, because obviously he's combining space and time.
Yeah. Well, I would personally say that if the ether exists, it exists as part of the universe. Whether it's, I've heard that it's a physical phenomenon, the ether itself. I would say that it exists on top of empty space. That if the ether does exist, and I'm unsure if it does, but I think empty space is inherent, and that physical phenomenon fills empty space. That's my personal view.
Like I said, I think it's a matter of semantics and stuff. It's probably a little bit deeper, more discussion to go into it than just a few words here. That depends on, how you have to get results. I've seen the results with the wave patterns I look at, and it comes up with, it's one step lower than what Andy has. It explains how the energy gets distributed throughout the space, and how the energy distribution basically defines space, and also how the energy distribution can become part particulate in that. So it basically it goes along with what Andy's saying. That's why I asked him, does it do graphics? Because I would like to see the graphics where the waves are shown. So I think we got a lot of discussion to go about in that direction, Andy and I, maybe.
Well, what is your view of his conception of 0 and 1? I haven't never grasped that. And
my only conception is that that's the extremes. Everything is defined between the numbers of 0 and 1. Everything is a fraction of. There's the 1, which is the whole of space, and there's the 0, which is nothing. And everything is defined in between. Everything is a fraction of that space, basically. It's a different kind of math. Instead of having infinity.
Jim is here and he talked about the contradiction. If I'm not reducing binary mechanics, it did remind me of that, the conception that you, Jim, described. The binary nature of the universe.
Well, I did have an exchange of emails with Andy some time ago, and he even ran binary mechanics through ChatGPT
right.
and so forth. which I thought was sort of cute. But I have to also agree with Cornelius in terms of the semantics. The way scientists talk about this is operational definitions. How do we define operationally in terms of actual procedures or measurements for the concepts presented? And as far as I can see, perhaps this is a little bit too harsh, but I really don't see any operational definitions. In other words, I really don't see any science in what is being presented.
Okay. I'd like to move on to next topic if everybody's done with this. Andy didn't come back, and so I guess he can't defend himself.
I hope we didn't drive him away.
No, certainly not.
Really nice talk.
Like you said,
I'm not really sure whether he felt he was invited to participate in the second meeting.
Yeah. Well, I'm glad you did invite him, Harry, to that. I think it was a very informative discussion with him. Thank you. But yeah, like you said, without him, we might as well move on to the next thing.
Okay.